Hiya guys, Terry from Smoo's Workshop here. Right, we're going on to part 2 of my electrickery series. Now, yeah, it'd be lovely to just dive into the deep end and say, right guys, this is how you make all your LEDs flash in order and all that sort of stuff. Which is quite simple to do. This is actually a circuit from the Elionics website. It's freely available on the YouTubes. But there's quite a few components in here. Which I'll go into later on, but I mean, I don't want to baffle you straight away. 555 timer chip, decade timer chip, resistors, capacitors, rheostats, and a load of LEDs. Now, this particular circuit that's got a lot of lights flashing from one end to the other, this particular circuit can be modified for your night rider, where it goes up and comes back and all the rest of it. So this would be what I would be aiming towards later in the series. What I would say would be the more advanced. Yes, you can do it quite simply if you're into Arduino and stuff, but I'm trying to get you to understand basic components, and yeah, there's a lot of wiring and stuff kicking about here. But let's switch this off and get this out the way. So what is this section going to be about? Now, I've toyed quite hard on how to explain this to you guys, and a lot of guys have went and go right back to basics. So I'm going to, if you've got an understanding of this, this might not be for you, feel free to fast forward. Basically, I've got a few prompters on here. Understanding basic electronic circuits and how the electricity works. Then we're going to go on to voltage and amps, what they mean and how it works. Then we're going to go on to series circuits. And then we're going to go into parallel circuits, and then I'm going to go on to a brief outline for those of you that have seen the first video on the breadboard, a basic understanding of how a breadboard works and how we're going to use it in the experiments. So that's all I'm going to cover in this section. If any of this you guys already know, you don't need this, but I've been told to go from the basics, so I'm going to go from the basics. So, understanding basic circuits. So, you've got two types of electricity that we normally use. You've got the stuff that you plug into your power outlet, okay, which is AC, or alternating current, okay, which is normally symbolised like that. What we're going to be talking about is stuff that you get from batteries and power supplies, which is DC, which typically tends to go a bit like that. I'm not going to go into rectification and all that sort of stuff, but we're going to be talking about DC power. Okay, DC. What is DC? DC's direct current and AC's alternating current. Have I lost some of you already? Okay, right. You have a battery. A battery inside is made up of some chemicals and stuff. Okay, now on a battery, okay, so I'm going to draw a little wee 9-volt battery here at the side, okay? You have a plus and a minus, okay? I'll just put 9 volts on there. Hopefully I'm going to do this in a way you guys understand. I'm not trying to teach people how to suck eggs, but we'll go with the basics. So you've got a 9-volt battery. Now, I do have to explain at the beginning because there are people that are in electronics. We're going to be going by what we call conventional current flow. Okay. Now, any of you guys that have done physics will know the difference between conventional and what actually happens. So, in any circuits I'm going to talk about, we're going to talk about a circuit. So, what's a circuit? We've got a battery here. So, say that's a positive terminal. And there's going to be a wire coming off the positive, and it's going to go to something. Okay? It's going to power it up. And it's going to go back from whatever we've powered up, back to the battery, back to the negative, okay? Now, this is what we call, the power's going to go that way, okay, for the positive to the negative. This is what we call conventional current flow. It goes from the positive to the negative. In real life, it actually goes, all these little electrons go the other way. They go from the negative to the positive. But everybody nowadays talks about conventional current flow, so anything that I'm going to be describing is going to be conventional current flow where it goes from the positive to the negative. So what's in a circuit? So obviously you've got a battery. So a lot of this might seem like you're back at school. That's the only way I can describe it. But okay, so what have we got? We're going to have a battery or a power source, whether it's a DC adapter or whatever. Now, typically a battery is drawn like this, okay? One cell is like that, that being the positive, okay? And that side being the negative. So that would be like 1.5 volts. If we had another cell in, that'd be 3 volts. If we had another cell in, that'd be 4.5. Another one in, that'd be 6, and so on. So typically one cell's around about 1.5 volts, okay? Are you with me? I hope so. So we're going to go for the positive, and what do we want to put in? Right, so there's a negative bar along the bottom, and there's a positive. Typically, models-wise, okay, we want to be lighting up LEDs. So what is an LED? It's like a bulb, okay? So for this instance, the symbol for a bulb, we're just going to go like that, with a circle around it, right? Everyone's got wee symbols. So a standard circuit would be positive, it will come down, if a wee wiggle like that, that's the bulb, and back. So the power is going to go from the positive on your battery down to the bulb, light the bulb up, come back to the battery. That is the most basic circuit you can get. We're working on LEDs. Okay, so let's just do, doesn't matter how many cells it is, just got to do a battery. There's a plus, there's a minus. So we're going to come from the plus, and we're going to have an LED. Okay, now, I'm just thinking the best way to explain this, right? The next section will cover resistors and all the rest of it, but because LEDs, say this battery is running at 6 volts, okay? We're going to put an LED in, which is a diode, which I'll explain in the next one. And a diode, the symbol for a diode is this, okay? That's a diode, but an LED has that wee symbol on it, right? So we're going to have a diode in there, but most diodes run about 3 volts, okay? So if we run that back to the negative again, we have a problem. We've got 6 volts going in, 3 volts to the diode, we've got 3 volts to get rid of. If we don't get rid of this 3 volts, that diode's going to blow. The LED's going to blow. So what we put in line, doesn't matter whether it's in a positive or a negative, we put in a resistor, okay? And this wiggly line is a resistor. I will tell you later on how to calculate the value of a resistor, but this is the most basic circuit you can get. Okay, power goes for the battery through the LED, lights it up, comes back down the wire through the resistor, that gets rid of the 3 volts. Everything's all happy, hunky-dory. You can add switches in as well, so that's a switch, so that when you press the switch, the bulb comes on. Now, I'm hoping that gives you an understanding of what a basic electricity circuit is. There's power supplied, something consumes it, in this case an LED and a resistor. We'll talk later on about voltage drop, but basically what you want is if your LED takes 3 volts, you want your resistor to get rid of the other 3 volts. This is voltage drop, okay? You want the voltage drop over this part, which is 3 volts, and the resistor to be 3 volts. That must equal battery voltage. If it doesn't equal battery voltage, then you have excess electricity and something in that circuit's going to blow. If you don't have enough voltage, something's not going to light up or do what it's supposed to do. Hopefully that makes sense. It's a really basic circuit. So we've got 6 volt battery, 3 volt LED, a switch. This resistor gets rid of the 3 volts and back to the battery. That is a circuit. It is a loop. Now, if for some instance you manage to connect the positive to the negative, that's called a short circuit. That's bad juju, because basically the battery can empty itself, and what happens is whatever wire or whatever's in there is going to take all the power in the battery and it's going to heat up, it's going to melt, it's going to go on fire. We don't want that. Okay, so can I think of anything else in basic circuits? It's a basic circuit. Yeah, we've got a light source, a switch, and a resistor, right? that is the most basic circuit that you're going to have when you want to light up a model kit. Can I show you that in action? Yes, I can. So let me just put the cap back on this. So I find it easier myself if when you're planning out all your model kits and stuff like that, you actually draw little circuit diagrams with what parts are in it, what's connected to what, okay? How does that translate on a breadboard? Right, I'll go into breadboard basics later, but I'm going to show you what this circuit here is without the switch. So it's going to be, is it this one? Right, anyway, this circuit here without the switch. So we're going to have a diode and a resistor going for a power source, okay? So here's the breadboard. And this is what that actually looks like. So I've got a diode, a resistor, there's a plus, there's a minus. Right, so let me get my little... And again, I've never done anything like this, so if I'm not explaining it properly, you guys tell me, and I can go into more detail in another one or whatever. But right, let us get this. You will go into the board. A lot of people laugh about what they call cheap Chinese, can I get this in? Cheap Chinese breadboards. Sometimes the little pins in the holes don't line up. You need to put a wee cocktail stick down. So this red wire is going to be my positive. So I have a power supply here. So let me just... If you're wondering what I'm on about with my power supply, I'll show you in a second. So here's my plus. So this is simulating the plus from the battery. And this is my minus. So the plus goes in. Okay. There's an LED in line there, which is a plus and a minus, and a resistor, and a wee link down to what we call the earth there. Okay, so I'm just going to power this up. Right, there's no voltage on this at the moment. I'm just going to show you what I'm using. I'm using a proper power supply here, okay, where I can dial how many volts I want into it, like so. So let's look down at this most basic of circuits, which is... I'm using blue because it's a nice handy LED. It shows up well and it works at 3 to 3.4 volts. So I'm going to turn the voltage up very gradually. We're at 1 volts. It's not lighting up. 1.8. No. We're at 2.3. No. Right. 2.5 volts. That starts glowing. Right. And it's rated at 3. So let's turn it up to about 3. You'll see it getting gradually brighter. Right, that's that running at 3 volts. That is the most basic circuit you can get. So you've got your battery supply, a resistor and an LED. And that's what this is. Apart from it, there's no switch in this one. I could add a switch in, but we'll do that later. But basically, the diode is this part. That's symbolised by that. The resistor, this part, is in there. And this just stops too much current going through the circuit and it stops blowing the bulb. So it's learning to be able to draw out the circuit like this, the way you want it, then putting it onto the breadboard, get it working, and then you can solder it up. That is the most basic circuit. So if you're lighting up a headlight, all you're going to need is a battery, a wire, diode, some sort of switch, resistor, back to the battery. It's not rocket science, guys. So there we have a blue LED lighting up. Okay? So we're going to go from basic circuits and we're going to talk about a couple of things, voltage and amperage. Now, I've already mentioned that this particular LED likes to run it between 3 and 3.4 volts. Why do I run it at 3? You want these things to last as long as they can. If you run them at 3.4 volts, they're on their maximum sort of voltage and they don't last as long, so run them at 3. The amperage, when you buy LEDs, they'll give you a specification in milliamps, okay? But that's the maximum rating for that bulb. So the maximum rating for this little bulb is 3 to 3.4 volts, okay? 20 milliamps. That's the maximum. It's not the voltage that kills the bulb, it's the amps. Well, it's a combination of both. So let's explain what voltage and amperage is. So I'll just turn that off. Hopefully you're still with me and I've no bored you to tears. Right, so let's explain what voltage and amperage is. Now, the easiest way that I can explain it, and apologies, this is So voltage is the easiest way to think of it for me. Here's a water pipe, okay? And there's water in here, right? So the water flowing down the pipe has pressure, okay? The pressure is the voltage. Alright, so pressure equals voltage, right? Now, the actual flow, how quickly this flows through, is the amperage, right? So that's how fast it flows. So I'll just put how fast it flows. How fast it flows. Now, you noticed there I was talking about a resistor. So what does a resistor do? Now, if you've ever taken a pipe and then narrowed it down, like so, right? Even though you've got the same pressure pushing that water through the pipe, the water can only go through at a certain rate, okay? So you've got all this pressure, all this water coming up, and it comes to a narrowing. This narrowing is a resistor. What does a resistor do? It resists the flow of electricity through. Now, hopefully you can understand that. So I've got all this voltage and amperage coming up, but I only want so much. So I put a resistor in, which narrows the pipe, so the water or electricity can only flow through a certain amount. Hopefully that makes sense. But that's basically what voltage and amperage is. Voltage is the pressure that's pushing the electricity, and the amperage is how fast it can actually flow. And if you put a resistor in line there, it can't flow as fast. Therefore, it doesn't blow the bulb. Hopefully, you're still with me. Right, so what we're going on to now. Different types of circuits. Right, so the basic circuit I showed you was a simple, what we call, there's the plus, there's the minus, there's the positive rail, there's the negative rail. Most simple circuit, most simple series circuit is positive to your device. So in this case, it's going to be a diode, okay, an LED. So we'll just draw an LED in there. Through a resistor, back down to negative. That is what we call a series circuit. It's all in the one line. A series circuit is, let me put it another way. There's your plus. There's your battery cell, okay. And there's your minus. Now this time we're going to put more than one diode in line, right? We're going to put 3 in line. It's going to come back down. It's going to come through a resistor again. And back. Now, this is what we call a series circuit. The easiest way of thinking of a series circuit is a daisy chain. So we have, in this case, to run those we would need 9 volts. Okay? So each of these is 3 volts. Okay? So this is all diodes. Okay? So the first one takes 3 volts. The next one takes 3 volts, so you add those together. The next one takes 3 volts, so you add that together. That equals 9 volts. We don't have any excess voltage to get rid of, but we have to limit the current through them, because that one will take a maximum of 20 milliamps. That one will take a maximum of 20 milliamps. And that'll take a maximum of 20 milliamps. Not that we want to run them at the maximum, but the maximum you're looking at coming through there is 60 milliamps. If you don't put a resistor in there, you can get more than the 60 milliamps going through. So the resistor limits current. And when it limits the current, it also takes care of any excess voltage. There's a slight problem with this circuit, although it's very efficient. If, for some reason, one of these LEDs fails, there's a break in the circuit. It's what we call an open circuit. It's no longer complete. This bulb can't light up because there's no path to the negative. This bulb can't light up because the positive isn't getting to it. So the problem with series circuits is that if you take one bulb out, the rest of them fail. So if you bear with me a second, I'll set up for a little experiment and show you on the breadboard what this actually means when you're doing the bulbs. So bear with me 2 seconds. Right guys, welcome back. So on my breadboard here, what I've basically done is the exact same that's on this circuit. I've got 3 LEDs. In this case are green. Okay, so I'm not going to zoom into them, but I've basically got a positive feed coming in, and they're all daisy linked together through a resistor back to the negative, right? So I turn my power on. All 3 LEDs light up. Excellent, great fun. So these 3 LEDs are running in series. Now, the issue I was on about, if I take this LED here and take it out, the other 2 go out. This is something to consider when you are putting lighting into your kit. If for some reason one LED fails, okay, at the moment all 3 are on. If for some reason one LED, say this one, you know, wasn't manufactured as well, and you took it out, any other LEDs you have on the same circuit, the same series circuit, will also go out. This can be a problem. But to be fair, I haven't had many issues. Most circuits are made out of a combination of series and parallel. And for me, if one bulb goes out, the lighting's pretty much knackered on the kit. Series circuits tend to make best use of the power. For example, I've got this running at 6 volts. I'll just let you see. I'll scroll that up. So I've got this running on 6 volts, okay? And I've got 3 LEDs in there. They're running on 6 volts. And the resistor needs to be of a minimal value. Resistors, when I go into resistors, I'll tell you more about them, but they tend to lose the excess power and current via heat. So if you want to make your battery last longer, you don't want to be losing power through heat. And I'll cover that when I go into resistors. So although series circuits are a bit of a pain in the backside, if one bulb goes, they all go. I tend to run a combination of series and parallel. So now I'm going to talk about parallel circuits. So let's take this out. Right, so basically, as I explained, I'll just scroll the camera down again. Sorry, this is like a school lesson. I've already explained that a series circuit, they're all in a line like that. Okay? On a series circuit, like say your LEDs or whatever, anything that you have in line on the voltage all adds up. So if you've got 3 volts, it'll be plus 3 volts plus 3 volts. So if you actually wanted to run 6 bulbs on this, you would need 18 volts. It's not practical if you're using like a 9-volt battery. So this is when you have to sort of go, right, okay, how do I make best use of the 9-volt battery? I want to run 6 bulbs. I've only got 9 volts, so I can't run them all in series because I would need 18 volts. And this is where we go into parallel. Again, I hope you're all with me and it's not too much like a school lesson. So parallel circuits, right. So, the situation we've got here is we've still got 9 volts. Okay, so I'm going to go plus and minus, and, you know, doesn't matter how many cells, but yeah. We've got a plus and a minus. So there's the positive rail. Okay, and here's the negative rail. Now, I want to run from this, there's the minus and there's the plus. I want to run 6 bulbs. If I ran them in series, it'd be too much voltage. So we're going to do it like this. So here's a junction and there's a junction. So we're going to run the first LED, which is 3 volts. Okay. The second LED, which is also 3 volts. The next LED, which is also 3 volts. Right, so that gives us 9 volts. Wee problem there. I can't run any more on that on a series circuit. So what we do is we take a little branch off. Right, so we're getting 9 volts in there. But when we take a little branch off, we're also getting 9 volts to that one. So let's put another LED in there. It's going to run at 3 volts. Another LED in there. It's also going to run at 3 volts. Another LED in there. It's also going out at 3 volts. This also gives us a total of 9 volts. But what we've got there is 2 series circuits. But we're going to link them in parallel. And the way we do this is we're going to have a resistor for that first series circuit. We're going to have a resistor for the second series circuit. After the resistor, we're going to link them. And then we link them both back to the negative. So there's one series circuit. There's the other one, but they're linked in parallel. They're both running in parallel lines. In parallel, things work a little bit differently. But hopefully you'll get an understanding there. There is one circuit, but now they're both getting supplied with 9 volts. You can run 6 bulbs off of the 9 volts in 2 series circuits of 3. Right. As I said before, if you lose any one of these bulbs, if I lost that bulb, I would lose those 2. And if I lost that bulb, I would lose those 2. So there's another way of doing the parallel circuit for 6 LEDs. There's a plus, there's a minus, there's your battery. Okay. You would actually go for there with your 9 volt, right? Then you would have your LED, right? Then you'd have a resistor, and then you'd come down and you'd have another LED, and another resistor, then another LED, and another resistor, another LED, another resistor, another LED, another resistor, and another, is that 6? Another resistor. 1, 2, 3, 4. Right, so that's the same amount of bulbs, but then they're all connected after the resistor, and they go back to the negative. Now, it doesn't matter which one of these drops out, all the rest will still stay lit. Okay? Even if you lost 2, the rest would all stay lit. The problem with this one is, if you're still supplying it with 9 volts, and that's going at 3, each one of these resistors is going to be dissipating 6 volts. Which is fine, you can do that, but you're losing a lot of power to heat, which is why using combinations of series circuits in parallel works well. So I'm going to I'm going to go into my breadboard and show you what happens. Will I do it with 6? I'll do it with 3, so ignore the bottom 3, right? I'll do a parallel circuit with 3 LEDs in, the same green 3 LEDs that I showed you. But I'm going to do them in parallel and show you what happens when one bulb drops out. So just bear with me a second, I'll be back in a mo. Now, you'll notice this circuit is slightly different this time. I have a positive coming into the LED, and a resistor going to the negative on each one. These are wired in parallel. Okay, so I'm just going to hit the power on. You'll notice all 3 LEDs are lit. But if, for example, one LED fails, the other 2 are still on. This is why a lot of people prefer wiring things in parallel. It's not necessarily the most efficient way of using your battery power. If you're powering it on a mains DC adapter, it's not such a problem. But yeah, I can pull that one out. Those 2 still stay on. I take that one out. That still stays on. But then, okay, if I'd done that in series, if I'd pulled any one of the bulbs out, the rest would have failed. This is where parallel is an advantage if you want, I'm trying to think of the word now, redundancy. If you're putting LEDs into a kit and then you're gluing all the kit around it and one bulb goes, and you're quite happy if that one bulb went but the rest all stayed on, you're wanting to do it in parallel. Me personally, how often are you lighting up your kit? Who are you showing it to? Doing a combination of series and parallel is fine, but that is the difference between series and parallel, basically in a nutshell. All of these are getting fed with the same as before. I'm running them all in 6 volts, but they have a different value of resistor on them, and the advantage there is, as I say, one bulb can die and the rest still stay on. So it's something to consider when you're thinking about wiring up your kit. If one bulb goes, is it going to totally knacker up your kit? It would be if it was running fibre optics, because then all the fibre optics would die. It's a toss-up. As I say, I tend to run a combination of series and parallel to get the most, if I'm battery powering it, the most from my battery. So hopefully that explains the basics of that. What we're now going to go on to is, you've seen me plugging stuff into breadboard, but you don't really understand how that works. So I'm now going to explain how the breadboard works, and that'll conclude this section. And then the next one, I'm going to go into components and explain how they are, what they work, and stuff like that. Hopefully you're still with me. Hopefully I'm explaining it properly, and we're now going to go talking about breadboard and how it works. So back in a bit. Welcome back. Right, hopefully I haven't bamboozled you with talking about series basic circuits, series circuits and parallel circuits. Right, moving forward, we're going to be doing experiments on a thing called the breadboard. Now, this is one of the things that I told you on the first video, that is one of the things that you'll need. They tend to come with jumper leads like these, or I've got a nice little box of straighter ones that make things look a little bit neater. You can get them off of China. They're pretty cheap. So breadboard, okay. So we're going to look at this breadboard. You'll notice there's a red plus runs the whole length of this one, and a blue minus runs the whole length, and the same on the opposite side. But on this one that I've got the circuit on, the red only runs so far, then there's a break, then it carries on, and the same with the blue. Okay, so I've got a little image that I'll flash up just now. It's saying vertical, so it's talking about the breadboard looking at this way. It's talking about the get my teeth in, the vertical bus strips. This is called a bus bar, right? The vertical bus strips are continuous down the side of the board. So if you plug anything into the red one on here, it runs all the way up the red on this side and will be connected to there, unless there's a gap in it, like the other board, in which case you have to put a little jumper across. And the same with the blue one, which is typically a negative. If you plug a wire in there, anything that you plug in all the way up this row will be negative. And the same on that side. Okay? But they do not cut across the middle divider. So that's the first part. I'm just thinking what images I've got. Let's see what's the next image. Bear with me a second. I'm just flicking through my images here. Right, that's it. Right, okay. So again, the image I've got is talking about horizontal holes. Normally I would go that way, but yeah. So these horizontal holes, A, B, C, D, E, F, G, H, I, J, right? You're noticing they're in groups of 5, right? So I'm just going to flick up an image, and it shows you that anything that you plug in on one of these rows is connected to the other 4 pins on that row. And the same on the other side, but they don't cut across the centre divider. Okay? So this allows us to connect our positive power and our negative power with little jumper wires onto one of these rows, and anything we plug into that row, say we plug, I'll go into it in a minute. If I plug a positive, right, let's say, let me get a wee jumper wire. Might as well explain this fully. So, come out with the tweezers. Right, so I've got, yeah, right. So I've got a little positive wire here, okay? So, if I connect this positive into this pin, right, into here, and then onto, it doesn't matter which row, any row, but if I connect it into this row, it means that anything on this row of 5 pins will now become positive. So you can connect the positive of your component into there, right? For example, it may be an LED. So here's an LED. The longer pin's always a positive. I'll go into that when I go into LEDs. So I would put the positive pin, the LED, into there, and then the negative into the next blank row. Okay? So, on the next blank row, I would want to put a resistor. So, I put the resistor on there, on the blank row, and then take that to the negative, the blue rail. And that is the most basic of circuits. So we have, obviously I would have power coming into the battery, so you'd have your plus plugged in there and your negative plus plugged into there. So the plus comes up into this row. The positive leg of your LED is in this row. Your negative leg of your LED is in the next row. And that then goes into the resistor, down to the negative. That is a basic circuit. Okay, the breadboard can also be used for, and it's not till we go into the advanced stuff, so if you just want to light up, you know, a bulb, the breadboard can do it with that. You get little IC chips. This particular chip, let's see if I can get it to focus. This is a 555 timer chip. I don't know if it's going to be bright enough to pick up. The way the centre divider works on this is it allows you to plug in IC chips. Okay? We'll go into it later on, but one side will be positive, one will be negative. There'll be certain inputs, outputs, and all the rest of it to make it do stuff. But the breadboard also allows you to plug ICs in along the middle. And that's basically a breadboard. I'll flick up a quick image. I think I've got one. Let me see. As I say, this is Breadboard Basics. So anything that we're going to be doing experiment-wise, once I've done all the components, right? So the image I'm going to flash up just comes up just now. And it says the divider or gutter allows an IC to sit in the board without shorting left and right side pins, which is basically what I've just showed you. So basically when the IC's in, you've got another 4 pins on either side that are all connected together, a bit like this. And that's all a breadboard is. They typically have a sticky back. Some of them you can remove the side parts and all that, but that's what breadboard is. And you connect them all with a series of jumpers and wires. For example, say this was the positive pin of this IC. You would, anywhere on this row, you would go into the positive rail. Oh, apologies. Right, better doing it with my fingers. Positive row, anywhere on there, as long as the positive was connected to any one of those 5 pins, that chip would now get a positive on there. And again, you could put the negative on that side, any one of those pins, and connect it to the negative rail. And that's basically how the breadboard works. And you connect everything up via a series of jumpers. So as long as you remember the outside ones, the red and the blue, go that way. And all these little lines of 5, each line of 5 is connected, but that line of 5 is not connected to that line of 5. Hope that makes sense. And they're not connected across the middle, which allows you to put little chips in. Hopefully, this has run a little bit longer than I thought. I still don't know quite how to do this series. I hope I'm not making it too simple. I hope I'm not making it too difficult. The next part in the series, I'm going to break it down into 2 parts because we're going to do the basics. I'm going to talk about LEDs, what kind of LEDs you can get, how they work, and stuff like that. So I'm going to talk about LEDs and diodes, and I'm going to talk about resistors and how to work them out, how to tell what resistors what, and then we'll go into some experiments on the breadboard. And then at a later date, when we go into introducing other components like transistors and capacitors, then I'll talk about what a transistor does and what a capacitor does. Hopefully I'm doing this justice. Again, the only way I know, guys, is if you put a little comment down in the comment section. As always, do feel free to support me on Patreon. Again, I'll put the wee link up there. You don't have to. Helps keep the channel going. I'm not working due to ill health, but yeah. Hopefully at the end of this you'll have a basic understanding of how LEDs work, and a basic introduction to a breadboard. And in the later ones, you might actually get to, once I do soldering and stuff like that, being able to put LEDs in your kit, guys. It's not rocket science. Hopefully I've explained it. Maybe I've went into too much detail. Maybe I've waffled. Let me know in the comment section, guys, because I've never done anything like this before. So it's Terry from Smoo's Workshop here. As always, enjoy your hobby and happy modelling. Bye.